From ContainerDays Hamburg, this video is proudly presented by DAX-IT.
So today I'm going to talk about building an AI platform, specifically an LLM platform for running LLMs. So who of you uses LLM regularly? So quite a large number of people. This is an intermediate or introductory talk, so it's really, the goal is really to kind of get you started if you're thinking about building maybe an LLM platform in your work or maybe just in your home lab. So how do we typically, or how do most people today use LLMs? It's by subscribing to some cloud-based LLM service. Some of the most popular are OpenAI, GPT, of course, Anthropic, Google, Gemini, but there's a plethora of other services. What are the advantages? Of course, it's very easy to use. You don't need any technical prerequisites, you just need a browser to use them. You also don't need any technical expertise of how to run LLM, and you don't need any specialized hardware. So that makes it really easy to consume these services. So why then would you build an on-premise AI platform? First of all, it gives you the complete control over what models you may use, which is a big advantage. Because it allows you to select exactly the model that best fits your specific use case. And that might not be the same model every day, but really just specific model that is the best fit for the use case at hand. It also means that you can chain several models to create very powerful AI workflows. You might use a model to do image recognition, another model to generate some text. So yeah, it gives you a lot of freedom to create a very, very good solution. And of course, there's a problem with all LLMs. They might be biased. So having a pool of different models instead of just using the same model every day also protects you from this biased output of some of the LLMs. Another advantage of deploying the LLM model yourself is that it gives you a high degree of customization and ability to fine-tune the models. So fine-tuning really means that you retrain parts of the model parameters with your own data set. So you don't really retrain the whole model, but just some parameters of it, or maybe add an additional layer. And this means you can really customize the model to your specific organization or the specific data that you are tending to use it on. Another advantage is that it allows you to easily augment the models through a process called RAG. Just because, of course, if the model is running locally, it's quite easy to connect it to local data, like databases, knowledge bases, ERP systems, and so on. So it makes it very, very easy to do that. Yeah, a big reason why many organizations are looking into hosting the LLM themselves is, of course, the topic of data security and sovereignty. So for many organizations, it's just not acceptable to basically provide or ship sensitive data, like maybe customer data or patented data. Basically, yeah, sensitive business data, and to share it with third-party services, like a cloud LLM. When you instead host the LLM on-premise, of course, it means that this data never leaves your network. Right? So you don't have this risk of leaking data to a different entity. And then, of course, you have also compliance that many organizations need to adhere to. So that means not all data should be processed and should be fed into the LLM model. There might be some policies around that. And if you deploy the LLM on-premise, you can build any kind of guardrails around it. So it gives you also much more control of how your users are making use of the model, and it really allows you to make sure that it meets all your organizational policies, but also like compliance or your local regulations. Then there's also a cost factor. So of course, if you just get started with LLM, then from a cost perspective, the best way is just to subscribe to a service, right? Because you don't have any initial investment. But as soon as your consumption of LLM rises in your organization, it might, first of all, become, in the end, cheaper to run LLM on-premise. And most and foremost, it gives you more control over the cost, because the main cost of running LLM on-premise is the initial hardware invest. And so you exactly know what hardware you're buying and what you're investing, and it gives you more control than if you're buying a subscription where the usage is measured by tokens and where you might end up with a ginormous bill at the end of the year. So let's look at some of the available open source models. This is just like a very short list. There's many more to choose from. One of the most popular ones at the moment is Llama from Meta. This is considered one of the top performing open source models that's very close to the proprietary LLMs. It's a strong general purpose model that really is useful for a variety of tasks, including the text generation, summarization, and also some coding tasks. Then another one is Gemma by Google. What's interesting about that is that it's really built on the same technology that Google also uses for the proprietary cloud-hosted version, Gemini. And what's also popular for this is there's different models available. Some of them are smaller in size, and but still quite capable. And so they are better suited to run on like limited hardware, like maybe a laptop or less powerful GPUs. And then there's also Qwen by Alibaba. This is also a general purpose LLM, but is considered to be very strong in coding tasks and also mathematics. And it also is considered to be very strong due to its multilingual capabilities, because it supports hundreds of languages and dialects. As I said, this is just like a short list. There's really hundreds or thousands of LLM models available, and even more other AI models, like machine learning models. A great place to discover these models is Hugging Face. It's like a community for sharing AI models and training data sets. So I recommend you to check this out to understand what open source models are available for you to use. An interesting aspect is the topic of what is actually open source in the context of an LLM model. So for software, it's pretty clear what open source software means, right? So it always means you get human-readable source code for you that allows you to not only build the application from scratch in a repeatable manner, but it also means that you can really review the application and understand how it works. Another aspect of open source is typically they have very permissive, standardized licenses, like for example, Apache license or MIT license. With open source LLM, it's a bit different, right? Because there's really no source code of the model itself. So the biggest asset that you get for an open source model is really the trained model, which is basically a big binary blob. In terms of source code, what is available most of the time is the model architecture that's available as a source code, and maybe also some tool chain, some scripts, how this model was trained. But there is no really like a source code of the model. Some models, they also provide the training data set, but most of them really don't. And it's also not really that useful to have that, because I would say because it's virtually impossible to reproduce it. So you cannot really build such a LLM from scratch yourself using the data, using the training data, just because of the computational resources that would be required to do that. So that's quite interesting. And then there's also, if you look at the license of the models, they typically don't use the known open source licenses like for software. Typically they use some more restrictive licensing and more custom licensing. Just to give an example, so this is the license or part of the license from the Llama LLM. So first of all, it's quite permissive in an aspect that you can use it in a commercial context, and you're also free to redistribute it. So that means you could integrate this model in your own solution or in your own appliance and then ship it and sell it. So that's quite good. On the other hand, there's some interesting stuff also in your license. So I found this very interesting, where they say that if you have more than 700 million monthly users, then you need to request a license from Meta, which they might refuse. I don't know how many companies how many companies this is really applicable to. So I guess it's probably competitors from Meta, like another social network or something like that. So I found this quite interesting. So let's quickly look at the stack that would be involved if you build your own LLM AI platform. Of course, it starts with some suitable hardware resources, but that could even be a laptop with a powerful GPU, or of course, in the case where you really build it for production, it could be some IT server with GPU cards. Then, of course, in our context, we are always talking about running or building this platform on top of Kubernetes. And the first additional component that you then need is the NVIDIA or AMD GPU operator. Then you need some solution to really run the model. And there's a few of them available. The one that I'm talking about today is Ollama. We also need some interface for using the model. That could be an API interface if you're building an application on top of it. But if you just want to have like a chat to directly interact via prompts, then Open Web UI is the solution for that. And then the last one is not really necessary as long as you don't want to do RAG, where you basically add your additional data to the model. It's some kind of database. Doesn't have to be a vector database per se, but the vector database is supposed to be the most efficient solution for that. So let's quickly talk about the job operator. So GPU operator is the most popular one is probably from NVIDIA, but AMD, meanwhile, has also released an operator to make it, which makes it quite easy to also use AMD GPUs in this context. The operator is a Kubernetes add-on that simplifies the deployment and the management of GPU resources in a Kubernetes cluster, because this is actually kind of like a complex task to do. So the operator fulfills several tasks. One of them is the driver management. This is a big problem or a big challenge with running containers that need access to GPUs. The operator automates, first of all, the installation of all the drivers and libraries on the host. And it also helps you to maintain the life cycle of it, like regularly installing new drivers. So the cool thing about it is that you don't really need to access the host operating system and do any installation on that level. It's all done by the operator. Another thing that these operators have in common is that they install their own container runtime. So this is not really a full-fledged container runtime. It's more like a wrapper or a shim on top of another runtime like ContainerD or CRYO. And what this wrapping runtime does, it performs a few tasks to ensure that the containerized app can really make use of the GPU that runs on the host system. One of the biggest challenges is the topic of compatibility between the kernel or between the GPU driver and the user space utilities like the libraries, like for example CUDA libraries and stuff like that. This is a big challenge because they always need to kind of fit. So as soon as you update the point release of a driver, you need a matching library, for example, of CUDA to work with that driver version. And that's a big challenge because, of course, when you build a AI container application, you don't know while you build it on which Kubernetes cluster it will be deployed, and you don't know what driver version is available on these hosts, right? So this is the biggest challenge which this container runtime solves. Then the GPU device plugin is also an important part of the operator. This plugin implements the Kubernetes device plugin API. And basically, this API allows you to add additional schedulable resources to the Kubernetes scheduler, and then request these resources once you deploy your container application, just in the same way as you do it for memory or CPU, right? So if you look in the pod specification of your application, you usually can request like a certain number of CPU and memory, and the device plugin does the same now for GPUs. And this then means that when you deploy your GPU application, you don't need to make sure yourself that it somehow runs on a host which has a GPU. All this is fully automated then, and these decisions are done by the Kubernetes scheduler. Here on the right side, you see an example of configuring such pod with the GPU requests. Now, the Ollama is a tool that helps you to make it really easy to download and manage different models, and then also run these models. It supports quite a wide range of hardware, so really you can even run it on your laptop if you want, but you could also run it as a server application in a Kubernetes cluster, and then the interface would be the RESTful API that it provides. There's also a very nice official Python library for Ollama, which makes it quite easy to build like custom AI workflows just by basically interacting via prompts with the model that runs on Ollama. So this is a great way to get started if you want to kind of like build an advanced AI application just by interacting with an LLM model via prompts. Then there's OpenWebUI, which is a web-based interface for Ollama. It provides a user-friendly kind of like chat experience, like you know from the cloud-based LLMs. And it also kind of gives you like the capability to download new LLM models on the fly and switch between different models and so on. It also supports some advanced use cases. So it can connect to external data sources to do RAG and to kind of enhance the answers of the LLMs or enhance the context of the LLM model. So it can also answer questions referencing like internal data, like maybe a knowledge base of your organization. And then we have Milvus, which is a vector database, and this is essential if you want to do RAG, because you need some way of storing and then easily retrieving this kind of unstructured data, right? So typically, the data that you want to feed into the LLM context are massive amounts of PDF files, or maybe some wiki knowledge base articles. And a vector database is a very efficient way to do this kind of storage and then retrieval. Basically, the way it works is that when a user sends a prompt to the model, as you know, there's always a context that can be created. And basically, before the actual core LLM generates the answer to the question, this context is basically enhanced with data that fits to the question by doing this, by querying the database. So what are some of the risks with running LLM yourself? Of course, there's the usual risks and the mitigations for any application environment also apply for running AI applications, but there's also some specific risks for AI. So one is prompt injection. This is a vulnerability where an attacker like crafts a prompt that kind of seems not harmful, but it actually alters the behavior and maybe also circumvents some security measures in the model, some guardrails, to then achieve an unexpected result. So this might be used for different things. There was one example, I think a week ago, it was talked about where someone used prompt injection to retrieve serial numbers for Microsoft that were kind of stored in the model. So that's one example. Another problem is that LLMs, they always store the prompts from the user in a context, and this makes it possible to leak this data maybe to other users or to like different processes, different interactions with the LLM. So that's a big concern. And then, like any other application, there's also the risk that comes from the supply chain. We talked about kind of like the stack. So we talked about how there's different components that you are using to build this LLM stack. And that, of course, increases the risk that you get some vulnerabilities in the supply chain, depending on where you get these components from. Then we also have compliance risks. Especially in countries where there's a big concern about private data. And this also comes from first of all, the ability of the LLM to memorize the prompts in a context. And the risk that some of these private data, which might be like personal identifiable data, will then leak into different responses of the LLM model. And from a compliance point of view, another problem is also bias and discrimination. So any LLM in some way or another can develop a bias in certain aspects. And if you use such an LLM model in like a business context, it might lead to result that basically your business process becomes biased. Like, for example, if you use LLM to filter or sort through applications for job openings, and then this LLM shows a certain bias towards a group of applicants. This, of course, makes then your whole application process biased and potentially discriminatory. So let's talk about some of the best practices for running LLM on-premise. One important security measure is to implement guardrails. So first of all, guardrails are there to kind of manage the behavior of LLMs. And each LLM, or most of the LLMs, they have guardrails already in the model itself also, right? So these guardrails, for example, they prevent they prevent the model, for example, to explain the user how to build a bomb or something like that. Yeah? So each models have these guardrails already in them, but additionally, you should also create and enforce your own guardrails if you deploy LLM in your organization. And typically, you do that either via input guardrails, which means you're working on filtering on the prompts from the user before this prompt even reaches the core LLM. And the other way to implement guardrails is on the output side. So here you're validating the response that comes from the model before it reaches and before it's returned back to the user. So the main goal of implementing an input guardrail is to prevent harmful or malicious prompts from reaching the model. For example, in order to leak some data from the model training sets. And it also prevents user input that is harmful, like, for example, a user, as I said before, asking for the LLM to help with some illegal activities, or trying to jailbreak the model, or providing sensitive data to the model that your organization does not want the user to provide. On the output side, we validate the LLM responses, and this helps with a plethora of different things. So it helps with the bias problem. It helps to prevent toxic language to be returned to the user. And it also helps with other problems, typical problems of LLMs like hallucination. So what are some of the available solutions if you want to implement guardrails yourself? There's, first of all, Guardrails AI. This is a Python framework. And one of the great advantages of this, it kind of comes with like a marketplace. It's called, in this context, Guardrails Hub, where you can basically select what kind of guardrails and what kind of validators you want to use. And by selecting these different components, you can build pretty much a customized guardrails for your use case. Then there's also a similar solution from NVIDIA. And then, of course, there's always, or one interesting solution is basically just use a specialized LLM that has been fine-tuned to validate prompts and responses. So one example is Llama Guard, and this could be easily implemented in an AI workflow or in your own AI application by basically putting this model between the user prompt and the main LLM to then basically detect any prompts or responses that you don't want to have. So another important aspect is to implement supply chain security. So we're talking about basically building a platform with open source components. Most of them come from a community, and typically the artifacts for these components, you typically get them from the internet, not always from like sources that you can really trust as an organization. So yeah, the first thing that you should do should really make sure that all your software components come from trusted sources and that you understand who actually built these binary artifacts, who built the container images in this case. Another suggestion is to use SBOMs for all your third-party software to really understand what components are included, to help you also if there's some CVE and you want to understand if this component is affected by it, and to also make sure that you're compliant with open source licenses. And then throughout your own supply chain, which might start with your container registry, and then with deploying the image in your cluster, you should also implement best practices like CVE scanning for vulnerabilities. So one way that we as SUSE can help with that is by using our Rancher application collection. This is basically a big repository of popular open source applications where SUSE builds all these images from scratch, from source, and then distributes them via our own secure registry. And this application collection, meanwhile, also includes a lot of components that we are talked about today that allow you to build a platform. And instead of going to Docker Hub or to some source in the internet where you don't really know who built that image, and if it's free from vulnerabilities, you can go to a trusted vendor to get these images. Another recommendation is to adopt a so-called zero trust security model. Basically, the idea of the zero trust model is that instead of looking for known attack vectors or for known vulnerabilities, you define for all of your application components an allowed behavior, what this application can do. And this could be in terms of like networking, what services the application is allowed to talk to, what protocols it can use. But it could also be in the context of a container image, what processes are allowed to run in the image. So you define kind of like this allowed behavior. And then the zero trust model means that during the runtime of the application, it continuously monitors the behavior and compares it to the policies that you set for this application. And as soon as there's some violation of these policies, it's considered a potential risk. So the advantage of that is that it catches much more threats than when you're just looking for known vulnerabilities, like zero-day exploits or some malicious user exploiting your LLM. And so this is a big advantage. What my company provides here is a software called Neuvector, which is also a completely open source software. And one of the biggest advantages is that Neuvector does runtime security scanning. So that means it continuously monitors the behavior of your applications in your Kubernetes cluster. And it can compare this behavior with your rule set. And if there's any deviation or any anomaly, it can immediately alert you as a problem. So one example would be if maybe you built an agent or an LLM agent, and suddenly this agent creates an internet connection to an unknown internet service, and it sends some credit card data there. Neuvector can detect this because it does layer 7 inspection of all the traffic and the payloads, and it can really help you to prevent this kind of security risks. Another recommendation is to adopt an observability solution. I mean, this is a general trend, I would say, for cloud-native application management. But of course, it also applies to when you run LLM models on top of Kubernetes. Observability solution not only provides insight in generic applications, but you can use it specifically to get insights into LLM, like, for example, performance in terms of tokens, GPU usage, cost that is generated by the LLM. And this is achieved by collecting basically all the raw metadata that is generated on the cluster, like logs, metrics, tracing, and so on. And of course, my company also has a solution for that, which is called SUSE observability, and here you have an example of where you can instrument an AI application with tracing to understand. So in this case, it's like a AI workflow to really understand what are all the steps in this workflow, how expensive they are in terms of GPU resources and so on. So the final question is now, do I build this or do I buy it? So of course we are not talking hopefully about rocket science here. If you want to build an LLM platform, all the components are basically available for free from the open source community. So definitely building is an option. Obviously, if you do this in the context of an organization, it also creates a lot of technical debt, right? Because you first need to integrate all these different components, and then you also need to support it on the long term. So another option is to basically get the entire stack from a vendor who has already integrated all these components together and gives you a complete tested, validated stack, reducing the effort for running such a platform. And SUSE provides this in the form of a SUSE AI platform. And as you can see here on the right side, it's a complete stack starting from the operating system through your Kubernetes runtime and through all the additional services that we talked about today. So this is one example. Of course, there's also other vendors who do similar things. And with that, let's go to the questions.
Great talk, thank you. What do you think about VLLM compared to OLAMA?
Yeah, so OLAMA was really initially developed, I would say, for running LLMs on your laptop. But since it also gained a RESTful API, you can also use it in the context of a Kubernetes cluster as a service. VLLM is, I would say, on the long term, better suited for deploying LLMs on Kubernetes as a service. But yeah, today I decided to talk about OLAMA.
No worries. Giving context to models, you mentioned vector DBs. How does this tie in with using MCP to connect to things like DBs or metrics for RAG?
You have to repeat the second part.
How does this tie with using MCP to connect to things like DBs or metrics?
MCP. Yeah, I don't really know what was meant by MCP in this context. So I don't know, maybe the person asking the question could clarify. Otherwise, I would. Okay, yeah, even better.
Okay, I'm gonna repeat it again. So basically, in terms of VectorDB and MCP, MCP being just a protocol to connect tools or something, you would use the VectorDB as a storage and to find relevant entries in it. So you still need some way of actually like retrieving or like creating a query to get the data from the VectorDB, and you would return the results using MCP in that case. Also, if someone's interested, you can look at Miley Search, for example. It offers something like that.
Yeah, I would say there are two different things. So MCP is also kind of used to augment the LLM response, for example, with local data. But it's mostly also used like in a context of agents, building agents, to allow the LLM to interact with services. Yeah, so it's less about getting data into the answer. It's more about doing stuff in an agent context. Yeah.
Another question is, when running the AI stack on Kubernetes locally without a dedicated GPU, can I also run this on a MacBook with support for Apple integrated GPUs with Ollama?
Yeah, so Ollama supports Linux, Windows, and Mac.
Fast and easy. Which vector DB would you recommend and why?
Which?
Vector DB.
Okay, so I'm definitely not an expert on VectorDB. You don't need even a VectorDB to do RAG, so you could even use like a relational database, which has some extension for that. I heard that I think MariaDB has also some extension. So yeah, you don't really need a VectorDB.
A question about zero trust. How do I know which behavior should be allowed?
Yeah, how do I know which? Oh, okay. Yeah, okay, so that's a good question. So obviously, you need to define first the allowed behavior if you understand the zero trust model. And you don't want to do this manually, of course. This is just not realistic. You cannot ask all your developers to define policies for the allowed behavior. So the idea really is to do it by training and discovering in an automated fashion. There's different ways to do it in the context of NeuVector, which is a solution I quickly showed. You would run your application in a staging environment, which you do anyways, right? A testing or staging environment. And this is where the security solution analyzes the behavior and then automatically creates rules based on these behaviors. And then later on, when you go into production, you no longer learn, but you just compare the productive behavior with this rule set.
One last question. Do you suggest separate Kubernetes clusters platform for AI projects, or can we also create new node group with GPU in existing cluster with low latency?
I think there's no general rule to do it. Obviously, in the AI cluster, you need to have GPU resources, but that doesn't mean that you can also run non-AI applications there. You could have maybe 2 or 3 worker nodes with GPUs, and then you could have a number of other worker nodes that don't have GPUs, and Kubernetes takes care of scheduling the containers to the right hosts. So I don't think there's anything against that. Yeah.
Okay. I have one question myself. So you shown this SUSE Rancher product thingy in the end. Is this fully open source? Yes, no, part of it, none? Yeah,
so all the components in this stack are fully open source. Yeah.
Got it. Well then, thanks for your talk.
Yeah.
A round of applause for our speaker. And don't forget, this is the coffee break.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.